to this session. The first presentation is from Mr. Igor Pinheiro from Brazil, and the topic is about the application of AHP-TOPSIS-2N hybridic method for selection for an attack helicopter to be acquired by the Brazilian Navy. Very interesting topic. Mr. Igor, you can start. You have 10
yes,
minutes.
teacher.
Okay.
Hello, ladies and gentlemen. Good afternoon. My name is Igor Pinheiro. I'm a post-graduation student from Fluminense Federal University, Rio de Janeiro, Brazil. And it's a pleasure to be here presenting the paper entitled Application of the HP-TOPSIS-2N hybrid method for selection of an attack helicopter to be acquired by the Brazilian Navy. Firstly, presenting the main topics of the paper. The objective of the work was to apply the HP-TOPSIS-2N hybrid method for the selection of an attack helicopter to be acquired by the Brazilian Navy. The methods used were brainstorming technique for structure and model the problem. And for the evaluation and ordering the alternatives, we used HP-TOPSIS-2N multi-criteria decision-making method, comparing 6 helicopter models in the light of 7 operational and technical criteria. The results were 2 lists of ordering and prioritization of the alternatives, and the Apache and Mi-35 helicopters were chosen as the most suitable to be acquired by the Brazilian Navy. The methodology presented provided a rich and robust sensitivity analysis. In the presentation, I'll follow this outline. 1, introduction. 2, problem structuring. 3, background about the HP-TOPSIS-2N. 4, application of the method. 5, results. And finally, 6, conclusions. The authors begin the paper presenting some concepts important to understanding the proposed analysis, such as defining the National Defense Strategy, NDS, which is a document that aims to ensure the security of Brazil, both in peacetime and in crisis. For this, even in times of peace, it's essential that Brazil has modern armed forces, equipped and trained to guarantee its strategic interests. The NDS provides, under the leadership of the Ministry of Defense, the acquisition of attack helicopters. But considering this need due to the quantity, diversity, and complexity of existing models today, the task of select the best helicopter model is not simple at all. Therefore, this paper aims to apply the hybrid method HP-TOPSIS-2N to support the decision-making process for the acquisition of the best attack helicopters to be acquired by the Brazilian Navy. Presenting the problem structuring, among the main techniques for aeronaval war, we highlight the use of attack helicopters suitable for reconnaissance and air-fire support activities. This function nowadays is performed by regular helicopters of smaller size and with low firepower, which could be replaced by modern ones specific for these attack functions. Considering that the models of existing helicopters using the main armed forces of the world can be analyzed in the light of several criteria, whether qualitative or quantitative, this paper applied the hybrid method to support the decision-making process in the classification of these alternatives. In order to structure the problem, brainstorming technique was performed by the authors and Brazilian naval officers with high experience and acknowledgement in aeronaval war. Here we have the hierarchical structure of the problem. The main objective was choosing an attack helicopter for Brazilian Navy, 7 criteria: maximum speed, reach, maximum payload capacity, main gun, amount of main gun munition, number of rockets, and amount of air-to-ground missiles. 6 helicopter models were evaluated in the light of the 7 criteria: Attack, Mi-35, Catron, Tiger, Apache, and Viper Bell. Presenting now the background about the AHP-TOPSIS-2N. This method consists of 2 MCDM techniques that are usually adopted in complex scenarios: analytic hierarchy process, AHP, and technique for order preference by similarity to ideal solution, TOPSIS. This methodology has the following advantages: possibility of identifying the standard of the AHP-TOPSIS, and 2 current standardizations, which allows a sensitivity analysis of the results. The sensitivity analysis allows to generate decision rules to group the alternatives into sets. And the concept of hierarchy with weights associated with the conception of checking how much an alternative is closer and farther for an ideal solution, they are the main advantages of this method. There are 4 normalization procedures. The AHP-TOPSIS-2N uses N2 through the ratio between the difference of scores and the mean value of the scores, and the difference between the maximum value and the mean value of the scores. And N4 normalization procedure through the square root of the sum of the squares of the scores. The method has 9 steps. Step 1, establishment of the decision matrix, expressing the score of each alternative in relation to each criteria analyzed. Step 2, preparation of the weighting matrix using the fundamental scale of AHP through the evaluation alongside each criterion. 3, by applying the AHP method, the weights of each criterion are obtained. The importance of calculating consistency ratio should be less than 0.1 to ensure the consistency of the analysis. Step 4, obtaining the standard decision matrix. In the case of the AHP-TOPSIS-2N, 2 different normalizations and consequently 2 classifications are used. For this, the name of the method has 2N, 2 normalizations. Step 5, construction of the weighted normalized decision matrix. 6, obtaining PIS and NIS, positive ideal solution and negative ideal solution. Step 7, calculation of the Euclidean distance of each alternative in relation to PIS and NIS. Step 8, calculation of relative proximity to the alternative ideal. And finally, step 9, ordering the preference. Here we have the decision matrix with the 6 alternatives evaluated in the light of 7 criteria. And here we have the scores of each alternative in each criterion. The first step is obtaining the weights of criteria. And for this, the AHP-TOPSIS-2N uses the fundamental scale of AHP, a 9-point scale that transforms ordinal preference in cardinal values. After this, we obtained the weights of criteria. We can observe that the firepower criteria obtained more importance than the other ones: number of air-to-ground missiles, number of rockets, amount of main gun ammunition, and main gun. And we can see the consistency ratio equal to 0.05, less than 0.1.
3 minutes left for the presentation.
Okay. The results, we can see 3 clusters. And the conclusions: 2 forms of normalization provides richer and more robust sensitivity analysis. This feature gives more transparency to the decision-making process. And this methodology can be used for most diverse real problems of daily life. It suggested that this model of ordering distribution in clusters can be expanded in other applications, serving as a basis for decision-making process in the most diverse areas. That brings me to the end of my presentation. Thank you, and I'd be glad to answer your questions and suggestions by email or ResearchGate profile. Thank you so much.
Thank you very much. Are there any questions for the speaker? Are there any questions for the speaker?
Yes, I have a question, if I may.
Yes, of course.
Maybe I missed it. I'm actually interested in which one of those helicopters came out the best. Did you get a best alternative in your presentation?
The best alternative was Apache helicopter. And
Apache? Okay.
Apache. And in Brazil, the Apache was chosen like the most indicated for this mission. So
in other words, you're telling me that Brazil actually bought the Apache helicopter?
Yeah.
And it validates your decision process?
Yeah. I'm a Brazilian naval officer, and I work in a center of analysis, and that, how can I say, that helps the high administration to take this kind of decision, strategic and high level decisions.
It's always nice to have our decision work validated by actual doing it, you know? Very nice presentation.
Thank you, teacher.
Well, I guess I have one more question. Who makes that helicopter?
The authors. We analyzed the values after the method, and we group the alternatives into sets, considering the classifications. Like we use it to normalization procedures, it's common that there are differences between the normalization. So we can make a decision, a sensitive analysis, only observing these two classifications, observing what are the best alternatives in both scenarios.
Now, I was more asking the question, who manufactures that helicopter?
Oh, these helicopters are manufactured by several manufacturers. There are Russian, USA, Turkish aerospace from Turkey. Let me see. England. Yeah, there are these four countries.
Okay, thank you.
Did you buy from one of them or the other? Did you select the country as well, or just a model?
We've selected the best models, and not regarding the countries. So we've analyzed only the capacity of the helicopters without taking account the country.
I see.
So